A little more work and another explanation. Good Tuesday afternoon to you all, YouTube. It is 12:15. I am working on the bench project once more. That is the hole cut out with the bottom bell or top bell, whichever it is on the transformer. I don't know, but anyway, it's the bell from the transformer inserted into it, and I'll take it out and show you. There's the hole, but you can see it does fit in there very nicely, and you know that's back against, not quite back against the wall. In other words, I put it up here on purpose to see how well it was going to fit in that hole. So if I move it back there, it's even better, because there's more space back there than there is on this end. So it's going to fit just fine. Like I said, that's going to work out really well. Also, I wanted to point out these two notches here. I don't think I pointed those out on the front. They go into the in that groove on the front of the panel. I had to notch those out. There's just a couple of little places there that it needed a notch, so I did that. That's that step done. Now, next step, I want to get that bell mounted in there. Bill had pointed out made a good observation about this, and what I'm going to do, Bill, is mount the bell in there with screws as it is, flat, and then I'm going to see if I can put that on the back of the panel and see if that whole thing will slide in there. If it will, then I know I can get it in and out, and if not, then I'm going to have to do some more figuring. I think as soon as you slide it, see, I can slide it up a good ways before it hits anything, right there. And I think if you lift up at the same time, you can see, I think it'll work. I think it'll come out of there, but I want to make sure, just like you said, it wouldn't be any good if you can't get it out or in, you know. So I'm going to work on that now. I'm going to make a little bit of a side note here, and that's probably all the bench work you'll see today on here, because I have been working on the circuitry for the panel, and what I want to do is show that now and get that out of the way, and then if I have time, if there's not too much space taken up by that, I may come back in and work some more on this. I want to tell you a funny story. We had some storms go through the area yesterday evening, and I got so engrossed in the process of doing this circuitry that I'm going to show you, that I completely forgot my windows were down on the car, and my car got soaked on the inside because it was pretty good storms, heavy rains and stuff like that. So today it's about partly sunny, mostly cloudy. I'm watching the radar pretty close, and I've got the windows open again, hoping I can get this thing dried out mostly. It's a good warm day out there as far as the temperature, so you know it should dry out, I hope. But if not, I guess I'll sit on some wet seats. Anyway, let me get on. Stop flapping. I like to flap, you know. Let me get on with what I was going to do and show you the wiring for the power supply. I've come up with, I think, a fairly novel ideas on how to do this and still retain the both power supplies, the 0 to 330 and the 0 to 660 power supplies, using the same one switch and using just single meters, single voltmeter and single ammeter and single output. There won't be dual outputs anymore and like that. So you can see, you know, once you guys kind of check my work for me, I'll flash up the schematic of it or wiring diagram. You can let me know if I've messed up. Bob and I checked it pretty closely last night, and I think it is okay, but you know, having more eyes on it would be a better thing. So let me get you over to that, and like I say, I may be back on this. I don't know. We'll see. I'm back with you again at YouTube. As you can see on the screen here, it's 12:24 now. I've moved from the workbench to the easy chair, to bring you this little diversion. Taking a little break from the action of the building project and things like that. You saw that I had the bell in the bottom plate. Now it's at least cut out, and I haven't mounted it yet and tested it, but I will do that next. What I'm going to show you is I have completely, well, not completely, but redesigned the circuitry a bit for this power supply so that I can use a single output and single meters. You may recall my last design used the dual DC meters in both of those, and this one doesn't do that. So let me show you now real quickly. You know I don't do things quickly. This first one should be the 0 to 330 version. Let me bring that up on the screen. So there you can see the switch shown in 0 to 330 volt DC position. And if we look at the switch right here, now keep in mind this is a 4-pole, 3-throw switch. In other words, there is possible 4 inputs or whatever, and each one of those inputs can have one of 3 different positions. Of course, now they're switched. They're not switched independently. Each time you switch to 1, it goes to 1. All of them do, and all of them go to 2, then all of them 3. So anyway, you can see this is in the 0 to 330. If we follow the red lead off of the primary, secondary, I'm sorry, of the transformer, this is one of the high voltage leads. It comes through this switch here to this diode here, and if we follow the other one right here, it comes up through here through the other diode where they combine. This is a full wave rectification circuit, often used with center tap transformers, and which is what this is. We can see the center tap of the transformer, the red yellow wire here, goes up here and to the circuitry, the filtering resistor network that I've set up, and we can see the red wire, positive wire, goes through this resistor. Now this resistor may be relocated onto the other side. I don't know, I haven't decided yet, but anyway, it goes through the resistor onto the switch down here on the fourth pole, and you can see it comes through here and goes to the volt meter here, and then it proceeds on to the ammeter here and goes finally out to the output. The circuitry for the ground will follow that. Comes up here, goes to the ground side of the circuitry that I just outlined before, comes down here, over these wires here, and to this, goes down here, and goes straight out to ground. Now there is a voltage reference, I believe. I haven't got the meters yet, so I'm not really sure, but I think there's a ground reference on the voltmeter to where it knows, you know, to measure the volts between the positive and the negative. So I think that's the way. Now the ammeter, I don't believe, uses any ground reference. So that's the way that works. Now if we go, and this is in the 330 position. Now here's our 330 specs up here. Now these are subject to change also, especially this one here. That's a 2-watt resistor. I'm thinking about putting a 1/2 watt resistor in there, changing the value. Now all that is a bleeder resistor, and so if it's a little higher, that wouldn't matter. This I'm not real sure about. That's a pretty stiff cap for a transformer like that, and I don't know. We'll have to wait and see. May have to change that, half it or something like that. But for right now, that's what I'm using. That's what I bought, and we'll keep an eye on that, make sure everything's okay with it. Let me go to the other one real quick. Basically the same circuit, and you can see the switch is now switched. The switcher going down here. Now there's a middle position also. I want to point that out. If it goes into the off, nothing happens. There's no output. There's no voltage at all supplied to this. Everything just kind of flapping in the breeze here. There's no connections made. And so, but anyway, this is the 0 to 660 volt DC position, and we can do the same thing. Our red wire now goes this way through here, goes over to the full wave rectification here, and it comes out here with our positive leads, come out here, goes through the circuitry again. This one is fused on this side, 1 amp slow blow fuse, comes out to the switch again, back same way as the other one, and the rest of this is the same. It will measure the voltage the same way. I just put it to a different filtering circuit, and the rectification circuit is the only difference. Same way with the negative now. The negative comes for this, does not, let's see, where is the negative? There is no okay. There is no actual negative from the transformer on this one because we're not using the center tap. This just, the only thing we're using is the red and white and the red of the high voltage leads of the transformer himself. As you'll see, the other one comes here and goes this way, and that will become this end, and this will be basically our negative. I know it's not, it doesn't really work out that way, but we're just tracing the wires out, and we can see the filter caps here, which is the 110 microfarad at 900 volts, and a resistor, 120 k ohm. That's a bleeder resistor. That may not be necessary because of the way this is set up with the 270 Ks across the two caps. Bob says that should be sufficient for bleeder. It is common here with this negative. It's all together, and you see it comes out here just like the other one does, and it goes out. Now that should work. I think that is the way to go with this. It's obvious when this is switched this way, there should be no conflict with any of the other stuff because we're not in circuit. In other words, this is again flapping in the breeze, and this circuitry doesn't connect to anything anymore. You see, all this is just, there's no connection at all. This is just completely eliminated from the circuit. Same way with this one when the other one's switched in. So I think that should work out really well. Again, the meter will go up to 1,000 volts, so it should handle the 660 no problem. Amps is going to be a 0 to 999 milliamp. Bob seems to think 300 milliamps is the most in either position that can be gotten out of this transformer, and he said 300 milliamps is probably pushing it, so it's probably less than that. So anyway, that's what we're doing as far as that's concerned. I think that will work out rather well, I hope. It took me a while to come up with this, and even had Bob flummoxed a couple times on what I was doing because I wasn't showing him the whole picture. But anyway, so like I said, once we get this all together, this is going to be probably put the this circuitry here on a board and this circuitry here on a board, and then tie everything in. Now, obviously these two caps here and this big cap here is going to be probably attached some way to the panel to hold them in place, and then wires run over to them from there. Again, like I said, on the let's go back to our 330 again. On this one here, I'm not really sure if that needs to be on this side of before the capacitor or after. I think after probably would be better. I'm not really sure. It's only a 1/2 ohm 15 watt resistor. I think that's plenty. Again, I don't know for sure. We'll have to just play around with that and do some tests on it and go from there. But the rest of this is basically the same as it originally was. There's a 2 amp fuse here to protect the transformer. Now on the meter power, I don't have anything drawn in because I don't have the meters yet. They are both been shipped and on way, but I don't have them as of yet. I will be using the main power switch to power the adapters or whatever I use to give the meters their voltage, their supply voltage, to to make them work. I don't know yet whether I can use the same one for both meters. Sometimes there's a conflict if you do that, and I may have to go with separate power supplies for both meters, for each meter or whatever, and we'll have to wait and see on that. But anywho, I thought I would let you know that's what we come up with. I think it'll work. I was really, like I said, I was really kind of worrying about this because I thought, well, you know, I've got a 4-pole 3-throw switch. I should be able to come make this work with each individual filter. At first I was just going to have one filtering network for both supplies, and it would have been down in this area instead of, you know, being switched out. And then I got to, well, actually Bob suggested this. I'd already thought about this, but I thought maybe there'd be a conflict, and I didn't really go into it very much before I decided, you know, to just make a single filtering network here, down here, and go that route. But since he suggested it, I thought, well, okay, I'll pursue it a little further and come up with this. So I think this will work. I think it really will. So anywho, that's the plan. Whether it does or it doesn't, this is going to be the plan, and this is what we'll pursue. I doubt that I'll have much time left to go back into the other room and do that. I think probably I will just end this here and let you guys get back to what you're doing, and I will get back to what I'm doing. And I have to Lexi, I didn't have to take Lexi to work today because of the storm. She was out at her friend's house. There was a tree across the driveway, and they didn't want to get out there in the middle of the storm, try to cut it up so she could come home. So she just spent the night there, and he took her to work, and I was happy about that. So anyway, like I said, I'm just hoping my car drives out to where I can at least pick her up this afternoon at 5, and we'll go from there. So you guys have, in the meantime, you guys have a great day. Thank you so much for watching, and we will see ya.